My name is Sophia Ewens. I'm a PhD student in John Coates' laboratory, and I've been working with him for about 3 years in the department, but working on this project for about a year and a half. The Director's Student Fellowship is a fellowship that was inspired by collaboration between Shell and John Coates at the EBI, and so they have this funding set aside for a student that they believe would be conducting research that crosses the interface between the EBI and Shell's research vision. My project is inspired by the fact that right now we are in a global economic system in which energy production is slowly shifting from petroleum-based fuels to non-petroleum-based fuels, right? However, making that transition is often constrained by the fact that we still need economic growth during that process. And one option to replace petroleum fuels with alternative fuels is to use microbes to take CO2 from the atmosphere, which is now deemed as basically a pollutant, right? And transition that rather from a pollutant to a sustainable feedstock that we can use. And conceptually, this would basically be like replacing petroleum fuels with a brewed version of petroleum fuels where microbes can take CO2 from the atmosphere and make a liquid stock that we would typically be extracting from underground. In particular is focusing in on different energy resources that we can use to actually fuel this process. Because to actually tell microbes to take CO2 from the atmosphere and then fix it into products that we want requires a lot of energy, and that can be a bottleneck for actually developing this as a technology that we can use at a broader scale. And so I'm looking at different compounds that we can use as alternative energy sources that might be more scalable than the ones that we use today. And so what I'm going to do now is take a sample of these organisms that have actually grown up in those specific conditions and sequence their DNA to see if they are pure or if they're contaminated, and also what their identity is. I'm inspired by the fact that as a PhD student, I'm actually working on something that I believe is relevant to today's technology and to the problems we face today. We are looking at different energy sources that we can actually feed microbes to fuel the process of CO2 fixation into alternative fuels and bioproducts. I was motivated to get into science, generally speaking, because I care about the future of our planet and maintaining a sustainable environmental and energy landscape that can work together in our economic system. And when I say that, it sounds literally the same as the vision of the EBI, right? Is that I want to use science for a means of good in this specific subject, which is environmental sustainability. These organisms are essentially allergic to oxygen, and so we create an atmosphere within these sealed tubes that is devoid of oxygen. What's been unique about the EBI, and what's something that I didn't expect, was how diverse of a range of scientists are actually working in this institution. So I came into Berkeley as a PhD student studying biology, and when I joined the Energy Biosciences Institute, I assumed that it would be mostly focused on biology, but in reality, it's covering aspects from finance, economic policy, biology, chemistry, engineering. It's like so broad, and yet everyone has a similar like ethical vision, which is really cool to like blend that many different people together, working towards a common goal, but from different really diverse fields of expertise. And so from these gas lines, we get different gas mixtures that don't have oxygen in them, and so when you're taking a sample out of these tubes, you'll want to use a syringe that's flushed with this alternative atmosphere. And then that way you then don't contaminate the organisms that are actually in these tubes. I went into science because of this thing I care about, and this thing that I care about is environmental sustainability, specifically relating to how we use energy as a human society, right? And I can foresee that being my life vision. Like, this is something that I care about to the core and hope to commit my life to. So how that relates to career goals is flexible, because there are a lot of different ways to actually pursue that vision. But I hope to stay in scientific research. I hope to have the opportunity to continue researching what I'm researching now because it is actually really, really cool. This liquid in these Eppendorf tubes is filled with a suspension of cells that originally came from these glass tubes. And so these cells are now going to be spun down using a centrifuge. What this device does is once you have your samples sitting in the rotor, it will spin at extremely high speeds, and so these cells are at an angle, and so it'll pull things from the top to the bottom so that you can basically separate different parts of a mixture. In this case, we're separating cells from the liquid. So in this case, if you zoom in to the bottom, it might be hard to see, but there's a small dark spot. Those are cells. I also hope to expand upon that and actually communicate findings to the public because I find that that's a link that's often missing between science research and, for instance, policy initiatives or industrial initiatives, is actually communicating findings between those two. I hope to actually use my technical skills in science for a larger purpose beyond just research, and that would include both building tools with science that apply to industry, but also communicating the importance of our findings related to environmental sustainability to a broader audience. To me, sustainability means maintaining a healthy way of life now without sacrificing a healthy way of life in the future. We are not currently doing that because a lot of the impacts of energy usage and resource consumption are sacrificing these basic features of a healthy way of life now for future generations, and so in my mind that's not sustainable. However, I do believe that there are ways to actually approach maintaining a current way of life without making that sacrifice.